Triangle similarity. So our learning targets for this section are to prove certain triangles are similar by using angle, angle, side, 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 and side, angle, side for similarity, and then use the triangle similarities to solve problems. So when we were talking about congruence, I said that you cannot prove two triangles congruent by angle, angle, but you can use angle, angle to prove similarity. So if two angles of one triangle are congruent to two angles of another triangle, then our two triangles are similar. So here we've got angle K and angle Y are congruent, and angle J and angle X are congruent. And by our third angle theorem, we technically know that L and Z are congruent. But you just need two, and since I have two, I can write this similarity statement. Make sure you note that J is congruent to X, so J and X line up in the similarity statement. Alright, we did a side, side, side for congruence, and this is side, side, side for similarity. So when you have two triangles and you want to prove them similar by side, 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 your corresponding side lengths must be proportional. And if your corresponding side lengths are proportional, your two triangles are similar. So in this case, if we assume that our side lengths are proportional, then I know that AB to RS is going to be the same proportion as BC to ST and CA to TR. And then my triangles must be similar. Alright, third one, side, angle, side. And notice the angle is in the middle, so that means it needs to be the included angle. So let's say I only am given one angle of congruence. So in this case, X and M are congruent. Well, if the sides that create angle X and the sides that create angle M are proportional, then the two triangles are similar. So I know that X and M are congruent, but if ZX to PM is the same proportion as XY to MN, then my two triangles are similar. Okay, let's look at a few examples. So in example 1, we've been given that angle T is congruent to angle H, and I know that TU is congruent to TV and HJ is congruent to HK, but that doesn't help me with proving they're similar. What does help me though is knowing that if I have two sides that are congruent, that is an isosceles triangle. So my base angles are congruent. So that means that angle U is congruent to angle V, and it also means that angle J is congruent to angle K. So if we do a little bit of math, then I know that 180 minus 115 is going to give me whatever U and V are, like U plus V. So 180 minus 115 gives me 65 degrees. And I know that half of that, I'm just going to call it angle U. I know that angle U is going to be 32.5. degrees. Now, the same is true of J and K, and I can use the same process to find J and K. But since this is 115 and this is 115, then angle J is also going to be 32.5. So these two triangles are similar by angle-angle similarity. All right, let's take a look at number 2. I've got these two parallel lines, so I'll get to that in a minute. I've got a big triangle, LMN, and a slightly smaller triangle, PNQ. Now, they share angle N. So I only need one more angle to prove similarity by angle-angle. And I'm going to do it with these parallel lines. So remember, if you have two parallel lines cut by a transversal, corresponding angles are congruent. And M and Q happen to be corresponding angles. Well, you could also have used L and P because they are also corresponding angles. But you only need two, so you can stop there. So then these two triangles are similar by angle-angle. So in example 2, a building casts a shadow that's 78 feet long, and at the same time a nearby post is 5 feet tall, and it casts a shadow that is 39 inches long. So we want to figure out how tall the building is. Now, first you need to make sure that you pay attention that this is 39 inches, not 39 feet. So I'm going to do it all in feet since we're trying to figure out the height of our building. So if X is the height of my building, it pairs up with the height of my post, which is 5. And then 78 feet is the shadow cast by the building. And if I convert my inches to feet, I get that the shadow from the post is 3.25 feet. Okay, and now we're back to just doing our cross multiplication. So X times 3.25 equals 5 times 7/8. So we get that 3.25x is equal to 390. So X 3.25 is going to be 120 feet. So our building is 120 feet tall. Now, in example 2, we want a different building, but its shadow is 52 feet long. So I already know it's going to be a little shorter. And I'm going to call this one Y. So Y over 5, but it's the same setup, equals 52 over my post shadow converted to feet. And then when we solve our inequality, we should get that Y is equal to 80 feet. All right, last part of example 2. You and your friend are standing next to one another, and your shadow is 23 inches long, and your friend's shadow is 24 inches long, and you are 5'5". So how tall is your friend? So we need to set up an inequality, and I would go ahead and convert everything into inches. That would just make it easier for me, in my opinion. And then once we convert everything into inches, we can convert it back into feet and inches. So if my shadow is 23 inches long and my friend's shadow is 24 inches long, I don't know my friend's height. That's what I'm trying to figure out. And my height is 65 inches. So I've set up my proportion, and I get 1560 is equal to 23x. And when I divide that by 23, I get 67 and some change. So 67.8 inches. So your friend is 67.8 inches tall. And if you want to see that in feet, they're a little bit more than 5.5 feet. So they are 5 feet. I'd say 5 feet 8 inches. If we rounded this up to 68, it would be 5 feet 8 inches. Alright, last couple of examples. Is RST or XYZ similar to triangle ABC? So what you need to do is you need to look at your triangle and see if your proportions stand. See if all the sides are proportional. So you want to take the smallest and match it up with the smallest. And I can already tell that RST is not going to be similar to ABC because ABC has 3 different side lengths and RST is an isosceles triangle. So these 2 side lengths are the same. So it definitely can't be RST. Alright, so now I'm going to take my 3 and I'm going to look over here, and 6 is my smallest side. So if I want to write a ratio, then I could say 3 to 6, which is the same as 1/2. And now I can look at my middle side, and over here it's 4/8, which is the same as 1/2. And then if I look at my last side, 5 and 10, also the same as 1/2. So my triangles are similar by side, 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 similarity. And let's say I wanted to write a similarity statement. So my similarity statement would be triangle ABC is similar to triangle X, Y, Z. And just make sure that your sides are the same. So AB was proportional to XY. BC is proportional to YZ. So that's how it's laid out in my similarity statement. Okay, in example 4, I want to find the value for X that makes these 2 triangles similar. Now, they've told me that AB is in proportion with DE. So I'm going to go ahead and say that 27/18, that's one of my proportions. Now, I need to make sure that that proportion stays the same. So I know that AC must be in proportion with DF. So I can say 8x plus 1 must be similar to or in proportion with 22. So now I've got this proportion that I need to solve. And just make sure when you're solving stuff with 8x plus 1, for example, and you need to multiply that by 18, that you distribute it. So when I multiply 27 and 22, I get 594. And then 8 times 18 gives me 144x plus 18. Because I had to multiply the 18 by the 8x and by the 1. And now it's just simply solving this one or two-step equation. So 594 minus 18 gives me 576, and I divide everything by 144, and I get that x must be 4. So in order for these triangles to be similar, x must be 4. All right, next example. I want these two triangles to be similar. I know that VU and QR are my two similar sides. So I'm just going to go ahead and set up that proportion. And from my PQR triangle, I've been given this 3x plus 4 side. And over here, 20. So I know that 600 is going to be 72x plus 96. And now I just need to solve that equation. So x equals 7. And that's all you got to do. All right, so let's take a look at some of these practice problems. Do them the best you can, come back and check your answers, and use that to guide your questions. So here are the answers, and when you're writing the similarity statement, just make sure you understand that as long as your angles line up, it doesn't matter if our letters are in different places, as long as your letters line up with each other. So for number 1, for example, I could have written ECD is similar to EGF, and that still would have been a correct answer. All right, let me know if you've got questions.